All right, last example in the 3.3 notes. Find the fourth degree polynomial that has zeros of 1, 4, square root of 3 that has integer coefficients and a constant term of 24. Okay, lots of stuff here. So first of all, if these are the zeros, then those are also the x-intercepts, right? Zeros are synonymous with x-intercepts as long as they're real. If these are x-intercepts, then x minus 1 has got to be a factor. Same with x minus 4, same with x minus square root of 3. Zeros, x-intercepts, factors, again, synonymous. So I could have a polynomial. The number in front of it, the multiplier, the constant multiplier can be anything. It could be a negative 100, so I don't know any number in front of it. But it has to have a factor of x minus 1. It has to have a factor of x minus 4. And it has to have a factor of x minus the square root of 3. So if I expand this out, this would account for 3 degrees of the 4 degrees that are needed. So if I want a fourth degree, I got to add another factor in there. Now I could put in some multiplicities here if I wanted to, or I could multiply by just any, make another x-intercept. There's an x-intercept of 10. The problem with this is, if I expand this out, I'm always going to have this radical 3 in there. That radical 3 is not going to go away. So I will not have integer coefficients. So we need to figure out a clever way to make those integer coefficients. How can I make this square root of 3 kind of disappear so that I have nice rational numbers? Well, what's the nice thing to multiply by to make that radical go away? If I multiply by the conjugate, then I can use that difference of squares special product, I guess, to make that square root of 3 go away. So I'm going to choose to add an x-intercept of negative square root of 3 and have this factor so that when I expand it out, I'm going to get nice integer coefficients. Okay? So here we go. Y equals. I guess I need to express answer in expanded form. And I also need to make sure the constant term is 24. So that's going to require a little bit of work. Actually, I think I could do this without expanding it, but let's not. I'm going to multiply this one out. This is x squared minus 5x plus 4. This is a special product, square the first minus square the last. Ugh, I really don't want to do this. And I actually think I can avoid it. But again, the answer has got to be in expanded form anyway, so I guess we're going to have to do it no matter what. X to the fourth minus 3x squared minus 5x to the third plus 15x plus 4x squared minus 12. So there we go. And now, let's add our like terms and clean it up a little bit. X to the fourth. This is the only cubic. I have two squares plus x squared plus 15x minus 12. So now, this is my constant term. Well, after I multiply by the a, that'll be my constant term. That's got to be a positive 24. So that means my a needs to be a negative 2. If that's a negative 2, then whenever I expand it out, it'll be a positive 24. This is a fourth degree polynomial that has these zeros, these x-intercepts, has a constant of positive 24, and I also added in another x-intercept at negative square root of 3 in order to make these coefficients nice integer values. I would challenge you to try to do something other than this and make those nice integer values. I think you're going to have a hard time doing it. Okay? Very good.